Welcome back for my second video where we're making an FPS in Unity. In the first video, we created the project and managed to get some simple left, right, forward, back movement working. And now what we want to do is actually get gravity and jumping working, Mouselook working, and then put a few blocks in the level just for us to test to hop over, just so we can play around with that. All right, so let's go back to Visual Studio. And I fixed it this time. What I ended up doing that worked, once it reopens, was in the Solution Explorer, I just right-clicked this and told it to, now you don't see it here, but there was an option to reload with dependencies. And so I right-clicked that and I got reload with dependencies and it came back fine. So just a thought, if you run into that problem, you might want to try something similar. And I can tell that it is correctly reading Unity because mono behavior is now light blue. So it is recognizing Unity keywords. You can see that game object now changed color. So let's continue on modifying the update method. So we want to implement gravity, and realistically, most FPS games, we implement gravity ourselves because we don't use rigid body. So in between the normalizing of this movement vector and the actual movement, let's let's set up gravity. So if, and now we're going to access that character controller, so the variable, the lowercase c, dot is grounded. Now the character controller has a way of telling if the player is touching the ground. That's actually going to be something that we set inside of Unity. So is grounded is referring to I don't see that option. Oh, right here, layer overrides. Well, we can tell it to ignore certain layers. So it would be related to this, but as of right now, it's fine. So like if we're touching something, we're on the ground. So if our feet are on the ground, not if our head is touching the ground. So we will update our vertical speed by applying gravity times time.delta time. This is setting, so our vertical speed is getting set, so we're being pulled to the ground essentially. This is so that when we're going down stairs or ramps, we're still getting pulled down. If we just set it to 0, it wouldn't really work too terribly well. And then is jumping is false. So if we're grounded and try to jump, so if input dot get button jump. So there's a pre-built spacebar for jump. Is jumping. Now I don't really do much with this is jumping variable. And how this is a little bit of formula crunching here. If you take the gravity formula and you solve it for solving for velocity given a specific height, that's where this is coming from. So -2 times gravity times jump height. So this will give us an expected height of whatever jump height is. So 2 units. Hopefully I can get up to 2 units of blocks. It's not going to be exact, but it'll be in that ballpark due to the fact that gravity is continually adding every frame. So this is if we are not grounded. Then we want to apply gravity. Vertical speed plus equals gravity times time dot delta time. So it adds in some extra velocity to my vertical speed. Now let's attach the effect of my vertical velocity to this movement. So movement dot y equals vertical speed. And then we enact the move as normal. So this will now pull us down if we're in the air, and if we hit space, we will be able to jump. So if you need to pause it here, this is the entirety of, well, except for that stuff up there, but that was last video. You can tell from this green bar here is what I changed. So if we go over to Unity, it'll compile. Maybe it already compiled. So we hit play, and you can see that we dropped down, and now I'm able to move around. And you can see if I tap the key, I just move like a tiny bit versus holding it down. So it's a nice little smooth. And let's get Mouselook going, and then we should be pretty good to test this. All right, so we'll handle Mouselook after we do the movement. I should probably move this to a separate. Yeah. So let's kind of clean this up a tiny bit. Although, to be fair, this is designed only for the FPS controller. But I'm going to take everything inside of update right now. I'm going to cut it. I'm going to make a new method called move. Not on animator move, it's called move. And I'm going to put the code here. And then I'm going to just directly call move. And then I'm going to make another method called look, so I'll call it right here. It doesn't like me doing that. If I start typing look, press escape, it will let me call a method that doesn't exist yet. And so I'm going to make a new method here called look. So private void look. And this is going to be my Mouselook controls. So let's read the inputs. So float mouse x equals input dot get axis mouse x times mouse sensitivity. Now you could break this up into horizontal and vertical mouse sensitivity if you really wanted to. And then usually, in this case, turn rate doesn't need to be influenced by time.delta time, so we're not going to multiply it by time.delta time. If I have to do any kind of number crunching to that, I will. But for now, it's going to leave that. So if inverse Mouselook is turned on, then we'll just take mouse y and multiply it by -1. So if you want to flip your mouse controls, you could do that. So we're going to update the rotation of the camera. So this is an x-axis rotation, which is up and down. So like looking up and down, tilting up and down. So x rotation minus equals mouse y. And then we are going to clamp it. So use mathf.clamp. So clamp restricts it between two values. So -80 degrees and +80 degrees, so that you can't look straight up. Your head doesn't tilt all the way up. You can play with these, but this is minimum look angle, maximum look angle. So let's apply the tilt. So now there's a variable here that we called player head. So this is going to be, we'll have to attach the game object. Now we could search for the child inside of here, but I still prefer just to manually attach it. So player head dot transform dot local rotation. So this is a rotation relative to the rest of the, rather than a world rotation. This is relative to like the parent. Wonderful autocomplete right there. So we're specifying an X rotation of this amount and an X rotation to demonstrate. Like, I'll just rotate, well, we'll rotate the camera. So if I take the rotation, so if I have the camera selected, you can actually see on these axes that if I rotate around the X axis, you can see the camera looks up and down. So that's actually why it's an X rotation. Y rotation is the rotation where you're looking from side to side. So if you make a Y rotation, that's side to side. And Z rotations don't really make much sense, I guess, if you want the world to be upside down. So we don't really do a whole lot of Z rotations like that. So that's why this rotation's on the X. Even though we're looking up and down, it's an X rotation, what I showed. And now we're going to rotate the body. So this is transform dot rotate. Vector 3 dot up, so that's that y-axis that I was showing, times mouse X. Again, it seems a little kind of off that we're using X for up. Well, no, that makes sense. X is left and right, but we're using Y for an X rotation, which is up and down, but it works out. So this is our look method. You can see that this now is happy, and if we hit save, we should be able to mouse look as well. And this is it for the basic player controller. Obviously, we're going to add a few more functionalities to either this script or other scripts. So like being able to use objects. But for now, oh, we got that red error down here. The variable player head of FPS controller has not been assigned. So if you double click it, well, it will jump to the line where that error was happening, and that's just because I never attached the camera. So if I go back to Unity and I look at my script, you can see that I needed a player head here. So I want to put this main camera child down there. Now I should not have those errors. And now I've got a capsule collider, which I might move myself up a little bit higher. It's like being able to see your feet in an FPS. You just see the bottom of the capsule collider. And so it works out pretty well. You want to switch this to play maximize. I tend to find that to be a little bit less distracting. And then I click in, and so we've got the ability to look around. Now let's see how high I am jumping. So if I were to throw just like a few random cubes in here, let's reset that position. So I'm holding down Control to snap. So there's 2 cubes of, so that makes a height 2. Just to kind of test. Now you'll notice that, well, these don't have rigid bodies, so they won't move. But I do bump into them. So you can tell that the character collider is functioning as a collider. You do a little bit of platforming there. I would need to probably get rid of my capsule to make that easier because it obscures a lot of the view. So I could just turn off the renderer. And so now I can look down without, you know, that capsule in the way. So I said that I wanted my jump height of 2, and so this is 2 blocks stacked on top of each other, and I can clear that. So I've got my jump height of 2. Jump height, this would be 3, and we can see that I'm not quite getting there. I'm kind of about 2.5, I think. Because if I go from here, well, jump height of 2. Now, if we were to give these blocks rigid body, I'll just give one rigid body, then I'll delete these things. You'll notice that I'm not actually able to push it. And that's because I'm not interacting as a physics object. So despite the fact that this cube could have physics properties, the player is currently not participating in the physics engine. So that's something that we'll have to think about adjusting later on. The other thing that we want to take a look at is the character controller's ability to go up steps. So I guess let me just clean these cubes up a little bit. And what I mean by that is our player controller has a step height of 0.3. So that means if this block were 0.3, the player should be able to step on top of that. I'll let rigid body bring it down. So you can see that the player is able to walk over that. So like that's effectively our maximum step height. If we were to bump this up to like 0.4, we're not going to be able to go up it. Oh, I guess I did. Interesting. So I guess there's some level of give or take with that. So I was able to go up 0.5, but kind of what's interesting is that's 0.5, but the next one is 1. So regardless, you'll need to just make sure that you don't run into this type of issue with whatever objects you happen to be using. So like if we increase my step offset to maybe like 5, you can see that I have no trouble going up that. But this one I can't get up. So something to play with. Basically, the lesson here is playtest very thoroughly whenever you're messing around with this. So I'm going to delete these cubes because we're going to actually sculpt the land in the next video. And so that's it. We've got some basic movement, and so that will be all for this video. In the next video, we're going to learn how to use the terrain tool to be able to sculpt this into something cool. And load lots of assets and make it look pretty. All right, so I'll see you next video. Thanks for watching.